Hello, welcome again to another video lecture, and this time we will be discussing a topic in statistics, particularly the hypothesis testing using the t-test. Before we start, let me remind you about the process of doing the hypothesis testing. First step is to identify the null and the alternative hypothesis, and then the next step is to choose the appropriate test statistics. In this video lecture, we'll only be focusing on the t-test. T-test can be used or appropriately used for smaller samples, usually around less than 30 samples. The next step is to compute the p-value according to the test. And lastly, we will use our judgment based on the p-value, or we can draw the conclusion based on the calculations that we have made. For the first example, the Edison Electric Institute has published figures on the number of kilowatt hours used annually by various home appliances. It is claimed that a vacuum cleaner uses an average of 46 kilowatt hours per year. If a random sample of 12 homes included in a planned study indicates that vacuum cleaners use an average of 42 kilowatt hours per year with a standard deviation of 11.9 kilowatt hours, does this suggest at the 0.05 level of significance that vacuum cleaners use, on average, less than 46 kilowatt hours annually? Assume that the population of kilowatt hours to be normal. Now let's follow the steps that I have just stated earlier. The first thing to do is to set the hypothesis. Our null hypothesis is that mu is equivalent to 46, while our alternative hypothesis is that mu is less than 46. Mu here is what we call the population mean. The next thing here is that our level of significance is equivalent to 0.05. Since we are focusing on the t-test, we will be using the table A.4, or the critical values of t distribution. From the given of 0.05 alpha and the number of samples of 12, we can actually get the value of t, which is at the critical region. So from here, 0.05 alpha, and the number of samples is 12, but we will be using the term degrees of freedom, or DOF, or some other references just calls it DF. So DOF is the number of samples n minus 1. In this example, that is 12 minus 1, which is 11. So basing at V is equal to 11, we can get a value of 1.796. So that is our critical region. If we represent it using the normal distribution curve, something like this, then that value is somewhere here. So that's t is less than 1.796. Now, based on the steps in hypothesis testing, if our t value will fall under this shaded region, then our conclusion should reject the HO. On the other hand, if based on our calculation, if our t falls on the region except on this shaded one on the graph, then we need to accept the HO or fail to reject it. The next step here is to compute the value of t, and it is denoted by the formula x bar minus mu o over s divided by square root of n. X bar here is the sample mean, which is given in the problem. Mu here is the population mean, S is the standard deviation, and N is just the number of samples. So from the given, we can get a value of negative 1.16t. Actually, from this point, after getting the value of t, we can now actually conclude if we can reject or accept the null hypothesis. So, looking back at the graph of the normal distribution, negative 1.16 falls somewhere here. So, since um, since it is not on the shaded area, then our conclusion could accept the HO. Now, what if the problem requires us to solve for the p-value or the probability? Then we need to do one more step for that. And we will be using the same table again, the table A.4, which is critical values of the distribution. So we need to use this formula, which is the interpolation formula for the p-values, since most of the values of t are not written on the table. So we need to do the interpolation. So from here, the p-value of negative 1.16 is equivalent to p1 plus p2 minus p1 over t2 minus t1 multiplied by t minus t1, where t is the negative 1.16 and t1, t2, p1, and p2 later is on the table. Referring to the value of 1.16, let's go back to the table. And as you can see, there is no 1.16, particularly on the V of 11. But it falls within 1.088 and 1.363. In this case, this will become our T1 and 1.363 will be our T2. It follows that the alpha 0.15 will be our P1 and 0.1 will be our P2. Our P now is equivalent to P1, which is 0.15, plus P2 minus P1, that's 0.1 minus 0.15 over 1.363 minus 1.088, and then we will be multiplying this with t, which is 1.16 minus t1, 1.088. Now, solving for p, 0.13690, or this is just approximately equivalent to 0.137. So that is the p-value of the t less than negative 1.16. We have to test the hypothesis that the average content of containers of a particular lubricant is 10 liters if the content of a random sample of 10 containers are 10.2, 9.7, 10.1, 10.3, 10.1, 9.8, 9.9, 10.4, 10.3, and 9.8 liters. Use a 0.01 level of significance and assume that the distribution of contents is normal. So from the problem, we can say that our HO is the population mean is equivalent to 10 liters. On the other hand, our alternative hypothesis is our population mean is not equal to 10. With this, we can say that the test is a two-tailed test. The next step here is the level of significance alpha is equivalent to 0.01, and our DOF is equivalent to n minus 1, which is 10 minus 1, which is equal to 9. Let's represent the problem with a normal distribution curve. And since it's a two-tailed test, we'll be dividing the level of significance with 2 and get the area of the 2 as 0.005. And with this, we're going to go to the table and look for alpha of 0.005 in both direction with V of 9. So we'll have 3.25. Those are the critical values of the t. The value here is negative 3.25, and on the right side we have positive 3.25. Now the next thing to do is to solve for the value of t from the given values. Our sample mean from the given is equivalent to 10.06 minus the population mean, which is 10, and that is the value that we are testing, divided by the variance, which is equivalent to 0.246 divided by square root of n, or square root of 10. Our t is equivalent to 0.77. Based on the steps in hypothesis testing, let's see if it falls under the shaded area or not. So 0.77 is somewhere here. So it is not on the shaded area, and our conclusion should accept HO. So conclusion is to accept HO, or in other words, we failed to reject HO.